Hi, everybody. I hope you've had a chance to work on these problems by now. Let's go through these a little bit. If I'm going to find the key features and make a graph of this, I probably want to factor it some more. So I'm going to factor it down to x plus 1 squared times x plus 5 times x minus 5 for the numerator. And the denominator is going to become, let's see, I got x and x, -10, -3. I want -5 and +2. And I also noticed that I've got x minus 5 in the numerator and denominator, so it's the same as saying this, x plus 1 squared times x plus 5 divided by x plus 2, because I can divide out those x minus 5s to 1, but then I have to recognize that x can't be 5, otherwise they're not the same. So some things that I note on here. I have an asymptote at x equals -2. I'm going to have a hole at, let's see, 5, comma, and if I plug 5 into here, I'm going to get 36 times 25 divided by 7. No, 36 times 10 divided by 7 is 367ths. I'm going to have an x-intercept at 0, comma, -1 and 0, comma, -5, because that's what makes the numerator 0. And a y-intercept. You know what? I wrote those backwards. Let's try that again. I want the numerator to be 0, so that's going to happen at -1, 0 and -5, 0. And the y-intercept is when I plug in 0 for x. And for that, I'm going to get 5 halves. Last thing, if I think about the limit as x goes to infinity on this function, I'll call it f of x. Let's see, as I get really, really big, the numerator is going to get bigger a lot faster than the denominator because it's a function x squared. So this is kind of like having an x cubed over x function, which is like x squared. So I know that's going to be going to infinity, and the limit as x goes to -infinity on f of x, because it's similar to an x squared function, is going to be also infinity. The one other thing to note is that this +1 squared, that's going to make that -1 a double root. So it's going to bounce on the axis there. We're going to have a minimum or a maximum point at that spot. So let's see, x equals -2 is an asymptote. X equals 5, comma, 360 over 7, that's going to be way up there. That's going to be a hole. I know I've got an x-intercept at -1 and another one at -5. And I've got a y-intercept at 5 halves, or 2.5. And I know my end behavior is heading up in both directions. So I think I've got enough. I should probably check the limit as x goes to -2 from the left and the right. The limit as x goes to -2 from the left on f of x is going to be, let's see, I'm going to get a positive times a positive divided by a negative. That's going to be -infinity, and the limit as x goes to -2 from the right on f of x, let's see, it's going to be positive and positive, and that's going to be positive. So yeah, so that's positive infinity. Okay, oh, that makes sense, because if I'm going up on this side, I've got that bounce there, and down on this side, I've got the x-intercept. So I can kind of sketch in the graph like this. It's going to do something like this, and we got a bounce on there and head off in that direction like that. It's probably going to be more curved on the ends because it's going to look more like a parabola. But that's problem number 1.